I'm so excited to have so many folks here today for the very first session of Kubernetes Community Day. This is going to be a very introductory session, introducing some concepts of containers and Kubernetes. If that sounds like fun to you, even if you are somewhat familiar with Kubernetes, it will be fun because it's all illustrated and has fun analogies. But if learning the basics of Kubernetes sounds fun to you, you're in the right place. If you wanted to dive into something deeper, Ballroom G has a talk going on about like a website that is a front end for a database, for supercomputing, something cool going on over there. So if you wanted a deeper dive, maybe check out Ballroom G. But if you want to hear about introductory stuff in Kubernetes and containers, we are very excited to have you here. And we are, myself is Kaslin Fields, and I'll introduce myself a little bit deeper here in a second, but I am also here with Christina Weber. Would you like to say anything else about yourself?
I am Christina Weber. I'm a beginner at Kubernetes, so I'm going to be doing a demo later that is very much targeted towards beginners, from a beginner to beginners. I recently graduated a boot camp, a developers academy for full stack web development, and prior to that, I was a high school science teacher for 8 years.
I was about to say, round of applause. So I'm super excited that we're going to have a legit demo for beginners today. So you'll really get to see what it's like to start out with this stuff if you've never used Kubernetes before. So a little bit more about myself. I am Kaslin Fields, and I'm a developer advocate at Google. I was also an ambassador for the CNCF during their first generation of that program. They're working on the second generation of that program now. Applications to it just closed. But I'll be talking more about the Cloud Native Computing Foundation here in a few minutes. If you were here for the opening announcements, Taylor Dolezal from the CNCF talked a little bit about it, and I will say a little bit more. I'm also a contributor to open source Kubernetes in the special interest group for contributor experience. So my work in open source is all about helping to make sure that contributors to Kubernetes are having a good time, have the support that they need as much as possible, all of that kind of stuff. So if you want to join us in the open source Kubernetes project, we would love to have you. My focus areas are cloud native, DevOps, and especially, of course, Kubernetes and container topics. And I like to illustrate things, so you'll see my illustrations throughout this talk. And the topics I'm going to cover today, I'm going to do a very brief introduction to containers, just kind of a very high level. And then I'm going to talk a little bit about open source Kubernetes and its history. Then I'm going to go over the basics of what Kubernetes is and how it does it. And then we'll talk a little bit about ways to run Kubernetes before we dive into the demo. So first off, let's start by talking about containers. And so the first question with containers is, why do we even care about containers? And whether you're working for a toilet paper company or a company that runs an online store, all of the companies in today's modern world need applications of some sort. If you're running a toilet paper company, maybe you have logistics software or payroll software, all kinds of software. Josh, do you have a question? Ooh. Yes, please. Join in. This is one of my favorite talks to cover, so I'm so excited that we have so many folks who want to learn about Kubernetes today. Yeah. So no matter what kind of business you may be working with in today's world, you are having to deal with software applications. So the reason that we care about containers is because they help us run the applications that we actually care about. I think that's, yeah. Don't know what that was about, but we're good. Yes, resonance. So to put that another way, and to start the analogy that we'll be using throughout this presentation, the applications that we actually care about are like the chocolate chips in a chocolate chip cookie. If you are a chocoholic, like me, the chocolate chips are the reason that you're there. They're the most exciting part of the cookie. Same thing with containers. The applications that we actually care about are the reason that we're there using containers. So I'm going to use that throughout here. So to talk a little bit more about containers, the idea of containers is that they are taking the application that you care about and mixing it together with all of the dependencies that that application may need. How many folks are familiar with, "It worked on my machine"? Yeah, folks know that phrase. So the concept of containers is that we're going to take all of the things that the application needs and bundle it up into a convenient, portable, isolated package where it has everything that it needs and it's isolated from other things so that it's not getting messed with. So hopefully, whoever you give this container to will be able to run your application without having the "it works on my machine" problem. So the way that works, we're here looking at a container file. This is a Docker file. So in the case of Docker, and I like to talk about Docker as like a fantastic usability tool for containers. Because what Docker did is it came along and it made it a lot easier to work with containers. Containers already existed, but Docker introduced a lot of really convenient ways for folks to interact with containers. One of those things is the Docker file. So in our Docker file, we have a variety of different lines that do different things. So the first line here is a from line. And the from line in a Docker file tells us what base image we're using. And there are all kinds of base images out there. In this case, we have one that's called Golang 1.14. So from that, we can assume that we're going to be running an application in the Go programming language. So that base image gives us that already installed into the container. So that's kind of like the flower, the base of our cookie. Then we have a variety of other instructions here. Here we've got a copy line and a run line. So that copy line is taking some additional dependencies that this application is going to need. It's copying them into the container, and then it's going to run those dependencies so that we have all that stuff set up when we run the application that we actually care about, which in this case is just a hello world. But that's our chocolate chips right there. And then there's a line at the very end, which is either called entry point or CMD. And that's going to be the command that runs when you actually start the container. So essentially, this is kind of a recipe of saying, hey, computer, here's what I need you to do in order to run my application with all of its dependencies. The next step is going to be to build that. If you are a developer who writes code in any other language, you're probably familiar with compiling into a binary, which then someone would run. We're going to do something similar here with containers. We just described everything that we need to do. Now we're going to build it into a container image, which is kind of like a binary, if you're familiar with that. So to do that, in Docker, we use docker build, and here I use docker build dot, because it looks for something with the name Docker file. So it just went and found my Docker file. And from that, it created a container image. So at the end, it outputs this thing that says successfully built and a long string, because I didn't give it a cool name. So now we have a container image. And this is kind of like a cookie dough stage, where you could now give this container image to someone else, and they would be able to run your application without having to understand anything about the steps, just like you would give someone a binary of a piece of software, and they would be able to run that. So we compiled it into a container image, and this is just me showing if you run docker image ls, it'll output all of the container images that you have on your machine. So we would look for the one with that long string that it had outputted to make sure that we have that container image available. From there, now we want to actually run that. We want to actually bake our cookie into this convenient, portable, isolated little package that is a container, or a cookie in my analogy. So for that, we looked and we saw that we had our container image from the last step. And then we would run something like docker run. And here I shortened it. You can actually just kind of use a shorter, unique string from that long, weird string, and it'll find the right container image for you. So I just did docker run bd0, which indicates my container image, and then it will run the container. This is the output of docker ps, showing the running containers. I think that's the right command. And in this output, where I've run the thing saying, hey, Docker, tell me about all of the running containers, you can see that the image is bd0, so that's indicating that that's the right container image. And you can see that it's got a weird name, because once again, I did not name the thing properly. So these are the steps to creating a container. You write out the instructions, kind of like a recipe, you build it, into a container image, kind of like cookie dough or kind of like a binary, and then the actual running thing is kind of like our cookie. So the concept of containers is that it's going to make distributing your apps a lot easier because we are compiling it into that container image, which has all of the binaries and libraries, all the dependencies that your application needs, and it's going to run in this isolated package that is the container. So we're hopefully addressing the "it works on my machine" problem with containers. One more thing I want to say about containers is some of the benefits of containers that we often talk about are that they're often compared to virtual machines, relative to virtual machines. They are quite fast. They usually spin up in a matter of milliseconds. They take up fewer resources, because when you're doing a virtual machine, you're doing full hardware virtualization, whereas a container is essentially a process on the underlying kernel. So it uses C groups and namespaces, which I have other content about if you want to learn about how containers work at a lower level. But they take up fewer resources just to do the isolation that it does. And the security paradigm for containers is different from the security paradigm from virtual machines. But the reason I mention it is because there are all sorts of different ways that you can mix these components together. Maybe you want a container that's maybe a little bit less lightweight, maybe it's a little bit heavier, but the security model is a little bit more similar to virtual machines, which maybe you're more familiar with. There's a variety of different ways that we can mix these ingredients, just like you could mix the same ingredients and end up with different types of cookies. So there are a variety of different types of container runtimes, depending on what your needs are. People usually ignore this. People usually just use Docker. I think that's by far the most common way to run containers. And by the way, the container runtime within Docker, like I said, Docker is kind of a usability thing, really. But the container runtime that they use is containerd, which is the first one listed here. But there are also other things like kata containers, which are more similar to a virtual machine. So there are a variety of different ways to do containers. And we're going to talk about that more as we get into Kubernetes, which I'm going to dive into now. So let's start by talking a little bit about open source Kubernetes and its history. So we talked a little bit about the CNCF in the opening statements, if you got to see that. But the Cloud Native Computing Foundation is a nonprofit organization. They aim to be a vendor-neutral home for many of the fastest-growing open source projects, including Kubernetes, of course. You'll see that projects in the CNCF have 3 stages. They could be sandbox, where they are a relatively new project. They maybe don't have a whole lot of folks using it yet. Maybe the contributor community is just getting started. Maybe it only represents one company, something like that. Incubating means that it's starting to pick up steam. A lot more folks are starting to use it. Maybe it's getting closer toward being able to be used in production scenarios. Hopefully the contributor community is growing and becoming more robust. Graduated projects in the CNCF mean that it's being used in production at major companies. The contributor community is very strong, hopefully, and diverse. And so it'll be able to keep going for a long time. And that's essentially what graduated means. So the point of the CNCF is to help all these cloud-native open source projects. And I just want to give you a sense for what some of those projects are. You're welcome. So this is basically my life. So the cloud native landscape is a tool that the CNCF provides that can give you this huge, broad view at the kinds of software and open source technologies that exist for this concept of cloud native. And the way I like to explain cloud native is before the cloud, we were running things in data centers or locally on machines. And that had its issues, its challenges. And then the cloud came along, and it was a different paradigm for how we could run our applications on machines. Somebody else takes care of the hardware. We don't have to run our own data centers anymore. And we can just ask them whenever we want a new virtual machine, hey, just spin one up for me, and you can get one in a few minutes. As opposed to when you were in a data center and you had to order new hardware, and it takes a while for that to come in, and then you got to cable it. All sorts of things to consider there. So it changed the way that we were able to work with our machines. So all of the things that we consider to be cloud native are software that is designed to work in this unique environment that the cloud provided us. So today, we are going to be talking about mainly Kubernetes, which is a container orchestrator, which is just that little piece of this diagram. And this landscape, by the way, is like 2 or 3 years old at least. It's way bigger than this now. But I'm not diving into it in detail, so I haven't bothered to update it. But before this, we talked a little bit about container runtimes, which is actually over here, so I wanted to point that out. But from here on out, we are just talking about this one thing within the container orchestration block of the cloud-native landscape. So if you start getting into containers and Kubernetes and the cloud-native world, and you start to be like, huh, this is great, but I wish it did X, Y, Z, here's where you come to find the thing that does that. I have a whole nother talk where I dive into that. But let's go into Kubernetes. So here are some fun facts that I like to start with about Kubernetes. So the concept of Kubernetes is that it is a tool that manages clusters of machines that are going to be running containers for you. It's a distributed system. You've got a whole bunch of machines, and you've got Kubernetes over top of it, so that you don't have to think so much about the individual machines. Kubernetes kind of manages that part. It's an abstraction layer. It's inspired and informed by Google's experiences in internal systems. I do work for Google. But if you want to hear more about the history of Kubernetes, fascinating, wonderful stuff. I love learning about the history of Kubernetes. But it came from Google's internal system called Borg. And you can find the Borg papers, set of white papers that Google released about the internal system that Kubernetes is based on. So there were 3 folks, Joe Beta, Craig McLucky, and Brennan Burns within Google, who saw what we were doing with our Borg system, which did basically this thing of, we've got a whole bunch of machines, we've got this layer on top of it, we can just talk to that layer to make it run our applications instead of worrying about the underlying machines. And they decided, let's genericize that for everyone, and that's where Kubernetes came from. It supports multiple cloud and bare metal environments. So whatever cloud you're working on, you should be able to work with Kubernetes. I know someone who once ran a Kubernetes cluster on a bunch of Android watches. It's very flexible. A lot of folks run it on a set of Raspberry Pis. So there's all sorts of ways that you could run Kubernetes. The idea is that you've got some number of pieces of hardware, and Kubernetes is abstracting that for you so that you can run containers on it, which is kind of awkward to do on Android watches. Anyway, it supports multiple container runtimes. Like I said, most people ignore that there are other container runtimes, but if you wanted to use a container runtime that was not containerd, which is the container runtime of Docker, you could do that as long as it's part of the Open Container Initiative. I think that's the right OCI to use. And it's totally open source. Like I said earlier, if you ever want to get involved with Kubernetes itself, it's written in Go, so if you want to do programming types of things, you could learn some Go and work with Go by working with the Kubernetes project. But there's a ton of stuff in the open source community that does not involve programming also. The sub-project that I lead is about communications, making sure that folks within the contributor community know what's going on, and also that folks external to the community hear about the awesome work that contributors are doing. So there's all sorts of stuff you can do in open source. Come join us sometime. So the concept here is to manage your applications rather than managing those underlying machines. Fun fact, additional fun fact, I guess they were all fun facts. So the wheel of the Kubernetes logo, and the logo itself, is a heptagon, 7-sided. And that is actually a Star Trek reference, as well as Borg being a Star Trek reference. So when they started working on this project to genericize the concepts of Borg, the internal name for it was 7, as a reference to 7 of 9. So Star Trek fans, yeah. Always a nice fun fact. Like I said, the history of Kubernetes is really interesting. I also submitted a talk here actually about the history of Kubernetes as like a daytime soap opera, because it's got some drama. But there's a documentary for that. So each part of it, there are 2 parts, is 25 minutes. If you ever want to check out the history of Kubernetes, check it out. So now I'm going to dive into what Kubernetes is and how it actually does this cool stuff. So we're going to go over the whole concept of container orchestration, pods, replication controllers, scheduling services. So if you're familiar with these things, be aware that we're going to do some review here. So usually, I often talk about this without going over the container cookie analogy, but review, I like to talk about containers as cookies because we care about our apps, which are our chocolate chips, and containers act as a convenient, portable isolation mechanism for our applications. So we're extending that analogy to talk about Kubernetes, and here's where the cookie factory thing comes in. So a container orchestrator is something that is meant to orchestrate containers at scale. At Google, we run billions of containers every day because we run them for basically everything. So that's kind of where all of this comes from. So Kubernetes is kind of like a cookie company. Not in that it's where cookies are made, like the actual place where the cookies are made could be elsewhere, but it's really all about the logistics of running a cookie business at scale. Just like container orchestrator is all about the logistics of running your applications at scale across many machines. So this is running a cookie business across many locations around the world. So the basics of the Kubernetes architecture, we've got a control plane and we've got worker nodes. The control plane is like the brains of the Kubernetes cluster, or like the headquarters in our cookie business. It has the Kube API server, so the server that is running our API that we're going to use to interact with Kubernetes. It's got etcd, which is the source of truth. It tells the rest of the system what its state should be. Etcd is very important. The Kube scheduler, which we're going to dive into in more detail. Essentially, it takes the workloads that you need to run and decides where to run them. And then controller managers, which we will also dive into in greater detail. So I'll just leave that for a second. Then we've got worker nodes. And worker nodes are where our actual applications are running. So in a worker node, we've got a kubelet, which is kind of like the supervisor part of Kubernetes that runs on every single worker node. We've got our container runtime, because we're going to be running containers. So if you're going to be running a container using containerd has to be installed in that machine in order for it to do it. And then we've got the kube proxy, which I'm also not really going to go over. But so that's kind of like a warehouse, one of the many warehouses that is part of this cookie business. So talking about Kubernetes, which is a container orchestrator, you might think that it cares a whole lot about containers. It doesn't. Instead, it cares about pods. Just like if you think about a cookie business, they wouldn't care so much about individual cookies sold, they would care about packs sold. Kubernetes is the same. It packages up your containers into pods. So here's an example of a pod definition, which is like the pack of our cookies. And within that pod, we can have one or more containers. By far the most common use case is for a pod to have just one container running an application that we really care about. But it is possible to have more than one. And pretty much the only reason that you would do that is if you were doing some kind of a sidecar approach. So the concept of a sidecar application is, so one pod in Kubernetes has one IP address, and any storage that is given to it is shared by all containers within that pod. It's treated as a single unit by Kubernetes as it's managing things. So that means you can do cool things with it. Service meshes take advantage of this with the sidecar paradigm. They put a container right next to the application you actually care about, and then say some traffic comes in to talk to your application. The container that's next to it can intercept that traffic, say, hey, are you using MTLS encryption? Are you from an endpoint that I trust? And then it can allow it on to talk to the actual application if it is, or it can prevent that if it's not. So you can do cool things with this sidecar application. So any container that is in there with your main application that you really care about has to be very, very tightly coupled. It has to be something that's going to take advantage of sharing storage and networking. So that's pretty much the only reason you'd have multiple containers within one pod. Just a reminder that the worker node has these other components on it, I guess. So moving on from there, that's lovely. That's how we're going to run our applications in pods on Kubernetes. That's just the start of how Kubernetes helps you manage containers at scale. Core to that is the concept of Kubernetes replication controllers. So there's 5 different types of replication controllers built into Kubernetes. Deployments, which are really meant for stateless, long-running workloads. So some kind of workload that doesn't really need to store stuff, but it's going to be running all the time. a job is going to be something that spins up, does its thing, goes away. A cron job is going to be something that spins up, does its thing on a schedule, and then goes away, on a time schedule. Then daemon sets are for if you need to run some kind of workload on every node in your cluster. And stateful sets are for workloads that need to have storage. So say you're trying to run a database on Kubernetes. The stateful set was designed with some smarts to help Kubernetes know how to manage those types of stateful workloads. So depending on the type of workload, Kubernetes provides these different replication controllers, which will control how we scale those and manage those across all of these machines at scale. And we're here, at scale. So here's an example of an imperative command, which I won't dive into. We'll dive into that later in the demo, where we've got a deployment, which I already have highlighted, and we're scaling that up. Oh, I thought I highlighted it, but I didn't. So we're saying Kubernetes, hey, go scale this deployment up to 3 replicas. So you can see here we've got some kind of application running. Say it's getting a ton of traffic and we need more copies of it, we can go tell Kubernetes, hey, make more copies of it. There are also ways to do this automatically. There's something called a horizontal pod autoscaler that is built into Kubernetes. So that would allow you to say, hey, Kubernetes, when you see that this thing is getting a ton of traffic, spin up more copies of it, or spin down to fewer if you're getting too little traffic or something like that. So there are tools like that in Kubernetes. So this is where the scale starts to come in, is with these replication controllers. They also have cool things like deployments allow you to do a rolling upgrade of an application. So you've got 3 copies of an application running. It'll upgrade them one at a time. And it can also do rollbacks. So they've all got cool smarts built into them for those specific types of workloads. Replication controllers, very important. Oh, and I have the boring version of the diagram as well, is how I call these. So one thing I want to point out here is that you can see we've got a couple of different nodes, and we've got a deployment that spans them. Cool thing about deployments is you start to see that abstraction layer I was talking about with Kubernetes. So we've got this workload running, we can have multiple copies of it, we don't care which machines they're running on, just so long as they're running. So Kubernetes handles that part through the replication controllers. Speaking of which, so we've got these workloads that we're trying to run on Kubernetes. We say, hey, Kubernetes, go make those happen. You've got the machines, just do it. But how does it actually decide which machines get which workloads? What if you have a workload that needs something specific, like GPUs or something? Can you tell Kubernetes, hey, make sure that this workload runs on GPUs? Yes. So the way that Kubernetes determines which workload runs on which node is what we call scheduling in Kubernetes. And you can do some pretty cool things with it. So here's an example of another pod manifest. And one thing I didn't mention earlier with the pod manifest is right below that, we've got a metadata section with the name of the pod. And then we've got a labels section. This labels section can contain anything you want. It can be foo : bar. It's a key value pair. But these labels are actually very, very important. You can do anything with them, but they're actually used extensively in Kubernetes to do a lot of the cool things that it does. One of those cool things is this node selector. So here we've got a node selector in our pod definition. And so Kubernetes is this abstraction where we've got all of these machines underlying it. And within Kubernetes itself, it has objects representing those nodes. So since it's an object in Kubernetes, it can have labels. So if we were to put a label on our node in Kubernetes that says disk type SSD, we know that that node has SSDs on it. And then we can say, hey, Kubernetes, when you run this workload, make sure that it's on a node that has the disk type SSD label, which hopefully means that it has SSDs. There are also a few other things here. You can also use pod affinity or anti-affinity. You'll see that my boxes here in my analogy diagram, all of the pink ones are together and all of the green ones are together. You can say, hey, only put pink pods with other pink pods. You can also use anti-affinity. Make sure that you never put pink pods with green pods. And you can also use node taints and toleration. So that's coming from kind of the opposite angle, saying this node will only take pods with the toleration for that taint. So say it's a pink box, it'll only take pink workloads, something like that. So pod is from the pod perspective and node is from the node perspective. And those are called taints and tolerations, or we also use affinity to talk about that. So there are all sorts of ways that you can control how Kubernetes puts your workloads onto the underlying hardware. And here's the boring diagram of it. So you can see that the pod has a node selector looking for disk type SSD. The node itself has the disk type SSD label on it, so it's looking to match those. And the last bit of Kubernetes basics that I want to cover today is Kubernetes services. So we've talked a lot about how Kubernetes is going to run your workloads, but how do we get to them? It's not very much good if you can't actually reach the application that you just ran. So services are the main thing that you need to know about. I would say the base level thing that you need to know about in terms of the communication of your workload between other workloads, maybe between the workloads and the outside world. So there are 3 different types of services. So you can have a cluster IP type service, a node port type service, or a load balancer type service. Cluster IP is probably the most common type of service. It's really what services are designed for. Cluster IP means it gives your workload, say you've got a deployment that has a whole bunch of pods underneath it, you need some way to be able to take traffic coming to that and say, hey, go put it on one of those instances of the workload, right? So this is kind of a software-defined load balancer. And the cluster IP one is allowing that workload to talk to other things within the cluster, not allowing it to talk to things outside of the cluster. So if you have microservice architectures, say you've got a website and it's got like a payments app and like an inventory part, and all of these pieces are split up into their own services, as we say in microservices, then you can put a cluster IP in front of each one of those components, and then they can talk to each other within Kubernetes. Node port is how I started to learn Kubernetes. And the concept of node port is that you've got your workload, it's running somewhere on Kubernetes on a node. You can open up a port on that node, and you can be able to get to your workload from the outside world. You might see that this is kind of useless and doesn't make much sense, really, in the production world of Kubernetes, because the idea is that we're telling Kubernetes, hey, go run this thing. I don't care which node you run it on as long as it meets my requirements. So if you have to go find which node the workload is running on in order to get to it, it's kind of defeating the purpose. So it's useful for learning, and it's useful for debugging a little bit, depending on what you're using. But node port really isn't used very much anymore. But node port was important for developing load balancer type services. So load balancer type service, for example, if you're in a cloud provider, Kubernetes can use a special cloud provider. I don't know what they're called anymore. It's not called a plugin. But there's a special component that can be added to a Kubernetes cluster for each cloud provider that gives it some smarts about the environment that it's running in. So then when you run a load balancer type service, it can actually go out in the cloud provider and create a load balancer resource to put in front of your workload, so that you're actually using a real load balancer with an externally accessible IP for you to get to all of those different pieces of your workload. But if you are in a real life circumstance where you're running a website and you're getting a huge amount of traffic or something, really you want to manage that ingress, not just get to your application. So there is a separate concept in Kubernetes called ingress, specifically for that use case. So the services are like the baseline. It's kind of like a vending machine. You've gotten your application to the point where it's running. You need to get to it. You need to get it to some kind of end destination, hopefully within the cluster for services. But if you're trying to manage this huge amount of ingress, you're running some kind of major shop or something, maybe in our analogy, you're going to want to have ingress, which I don't dive into here. And I always forget that I have the boring diagram. So here you can see an example where we've got 2 deployments on a node. The deployment connects to a service. That service, through cluster IP, can allow it to connect to the other deployment. Or you can use load balancer, which will create a load balancer object. This is the Google Cloud icon for a load balancer, and then it can go to external machines. Or you can use node port to go through the node to an external machine. Yes, so like I said, I don't go over ingress more here, but if you're running a production workload where you're actually managing ingress to a website or something, you're going to want to dive into that. You should also learn more about the replication controllers. Like I said, they're useful for different types of workloads. If you're running stateful workloads, like databases and things, this is a huge really fast-growing area of workloads in Kubernetes. So you'll want to learn about persistent volumes and persistent volume claims, which are how Kubernetes manages storage and getting that storage to workloads. And namespaces are also a useful concept for you to learn more about. They are a conceptual way to organize your cluster and the workloads on it. So say you have one cluster that's being shared among teams, then you could create a namespace for each team. So the basic things that I wanted you to know about are pods, replication controllers, the Kubernetes scheduler, and services. So those are the baseline level of running your workload and enabling it to do some communication within Kubernetes. But beyond that, you'll want to look into these things. And the last thing I'm going to go over today is a few options for you on how you could run Kubernetes yourself and start getting familiar with all of this stuff. So the way that I learned was with Minikube, which is a tool provided by the open source project which runs a single node Kubernetes cluster on your machine. It uses virtual machines to spin up Linux nodes, a single Linux virtual machine, which then acts both as the control plane node of Kubernetes and as the worker node of Kubernetes. So it has a few weird things because of that, but generally speaking, it's a great way to test things out. If you're doing some development of an application that's going to run on a Kubernetes cluster, you could try running it on a Minikube cluster first. It'll generally be representative of what you need to know, unless you have like a ton of databases and stuff connected to your Kubernetes cluster in the cloud or something. But Minikube is great for local. There's also kind of a lighter weight way to run a local cluster, which is Kind, or Kubernetes in Docker. So this is super weird. You're taking containers, Docker containers, and using them to run Kubernetes, which is a tool for running containers. That is what is happening in Kind. It's amazing. So we're going to demonstrate that here in a minute. There are also cloud provider managed services, of course. I work for Google. Google Kubernetes Engine is one. Azure Kubernetes Service. Elastic Kubernetes Service. That one also service? EKS, yes. So whatever cloud provider you go with, the idea of their managed service is that you can click one button and then you get a Kubernetes cluster, and that cloud provider is taking care of the control plane of the Kubernetes cluster. So you just have to worry about running your workloads on the nodes. And of course, you can do self-hosted do-it-yourself. Run a Raspberry Pi cluster. I have a set of Intel NUCs at home that I run a cluster on. Run it on Android watches if you hate yourself. It's probably easier than it was, right? So there's also a tool these days called kubeadm, which can help you do this a little bit easier. They can be multi-node. There's also, by the way, a project called K3s, which is meant for smaller hardware environments. And that's all I've got for you in the presentation portion today. We're going to move into the demo.
While we switch laptops, we got time for one question right now, and then we can take a couple more at the end. So anyone have an intro question? Yeah, go ahead. Go ahead.
I've actually got a question for Kaslin. I'm mentoring a few new trans and women engineers who are brand new. And we were actually wondering if there's any learning credits or things they can use on the GC cloud to get started. Yeah.
There are a few cool things that you can do with that. What are they all right now? I might have to look up some details for you later. Let's connect on that. I know there is like a champions program of some sort that we started recently, which is, I don't know, like $200 or something. There is a cost associated with it, but you get a lot more credits with it, so it's a pretty good deal. So there is that option. But there are also some for learning, and I'll have to look up the details of those. I apologize that I don't have that off the top of my head, but thank you for asking. We'll figure that out.
I have a question. What do you use to draw your illustrations?
I use a tool called Clip Studio Paint, which is designed really for comic making, because I'm really into comics. So that is what I use. And on a Windows Surface Studio laptop, I think is what they call it now. I also have a Surface Studio, yeah. Yeah.
Let's do one more question while we set up. Anyone else? I'll run it back.
So the whole "it works on my computer" is a bit of a half-truth with regards to Docker. I think especially people who bought an M1 Mac quickly found out that building a container on Mac would not run on a Linux machine. How do you go about making sure that the "doesn't work on my computer" issue doesn't happen anymore?
I'm running back. Hold on. We should really have another mic.
A little bit since I was helping.
How to make sure that it doesn't run on my machine doesn't happen with containers, because it's still a different architecture, especially M1 ARM-based Macs.
Yeah, so the concept of containers is that they're using the built-in Linux kernel properties of C groups and namespaces. And C groups are a way to say this process gets this amount of processor power and memory. And namespaces are a form of isolation within the kernel. So as long as you have a Linux kernel version that is compatible with containers, that has C groups and namespaces, essentially, you can use it. So like there are Ubuntu base images for containers. Alpine is a really popular one that is like super lightweight, but there are different flavors of Linux that can be container base images. So within Linux, you're pretty much good. But within the Windows world, things get different, which I love to talk about. But Windows actually implemented their own native concept of containers within their kernel. So there's a separate thing for Windows containers. But yeah, within Linux, as long as it's got a kernel that supports C groups and namespaces, you're generally good. Oh yeah, with ARM versus, I don't know that much about that. Is that how you do it these days? Okay, you use build flags to address that.
An architecture. All right, let's go ahead and jump into the demo.
Can y'all hear me okay? Great, okay. All right, so first off, before I start, so a little loud. I think I already mentioned this, or if not, I'm sure Kaslin mentioned this, that this is just for beginners starting out. I am very much a beginner to Kubernetes, but I do have this in GitHub, so if you wanted to try this out on your own, it also has some install instructions. I am going to be using Kind, which is also going to require Docker. So if you wanted to try this out on your own local, you can. But I'm just going to walk you through it. Hopefully it seems pretty straightforward. So I already have Docker running. I do have this image here from Kind. You do not need that. If you're starting out for yourself, it'll pull that whenever we get to that point. But the first thing I want to do is I want to make a Docker image, right? So inside this package that I have a Docker file. And I'll just take a look at that with y'all. So you can see it looks very, very similar to the file that Kaslin has already showed us. We have our base image. I'm going to be doing Node.js. And the 19 Alpine, I think, is a very popular variant. And then I'm copying over my package.json, which has my dependencies, along with the actual file itself. And then I'm going to be running npm install to install those dependencies. And at the very end, my entry point, I'm using cmd, the command, is going to run whenever I actually run Docker. So I'm going to build the Docker image. It's going to run these things. You'll see that. It's going to cache the results. And then when I'm actually ready to use that image is when you're going to have that entry point run. So let's go ahead and build an image from this. So Docker build. And I'm actually going to name mine cookie app. And I'm going to tag it v1 for version 1. And then I'm going to give the path to where to find the Docker file. So I'm at the same route as I was before. And you can see that it ran all of those things. It cached those results, exported to an image. And if I open up my Docker desktop, I now have this saved on my local machine. It is not limited to local. Obviously, you can push it to the Docker hub, and you can pull things from there if you don't want to make your own image. But this is what I'm doing here. It now exists. I can also look at it here on Docker desktop and actually see the layers that it ran, including layers that I did not add that were part of that base layer. All right. So the next, we need something to actually run Kubernetes on. So I'm going to create a Kind cluster. So Kind, create cluster. And I'm not going to name it, so it's going to automatically name it Kind. What you'll notice is that it actually pulls up that image that I had in Docker. If I had not had that saved to my local, it would actually just pull it from Docker Hub. I was just trying to make it a little bit quicker, because when I was trying this out earlier, it was running a bit slow. All right, so we actually now have our kind cluster, so I'm going to look at it. Oh. Okay. I don't know. All right, so here we have Kubernetes control plane is already running for us, and it has a core DNS server. So that is already created by us, for us by kind, just already up and running. I did not need to go and do that. And I'm actually also going to look at some of the Docker images that it has available there. So Docker exec, T, or actually, let me go ahead and get the node so you can see that. Might be helpful first. I feel like I should have, yeah, okay. So kind control plane, so again, I didn't name it, so it's automatically named kind, and we have that control plane that we're gonna be able to use to run Kubernetes. But I just wanna show you the Docker images that it already has in here for kind. So I'm gonna do that now. Let's see this kind control plane. All right, and you can see that it already has all of these Docker images that were just part of that one image that we loaded from kind that's already done for this. You can see core DNS, you can see all that Kubernetes, as well as that stuff from kind itself. So now what we're gonna do is I'm gonna load the image that I created, because right now you'll see that it does not know that that app that I made even exists. So I'm gonna go ahead and load that. So using kind to load, I'm gonna load a Docker image, and I'm gonna give it the name cookie app v1 was what I named it. And then let's go ahead and look at the images again, and now you can see cookie app version 1 is the tag, and now it exists.
I want to mention that this is kind of a weird thing with kind, because kind is running within Docker containers within her machine. We've got to load the image onto the cluster in the Docker container so that it has it. If you were running it locally or you were on a machine that was part of the cluster, you, of course, wouldn't have to do that.
I still like kind, but yeah. So I'm going to go ahead and actually first, so we already have that one node that we're running, but right now I just want to show that we don't have any pods. So in order to actually run Kubernetes, we need pods to run it. And so I'm going to create that. In order to do that, I'm not going to create pods directly. I'm actually going to create a deployment. So it doesn't have to be deployment. She already talked about some of the other examples, but I'm going to use a deployment first. Imperatively, I'm going to create it, and later on I'll show you declaratively. Hopefully there's time. If I run out of time again, all of this is on GitHub, and you can try it out yourself at home. And hopefully that's easy enough for everybody. So I'm going to go ahead and create a deployment. And I'm going to name it Cookie Factory. And I'm going to use that image that I just uploaded called Cookie App, tagged v1. It's created, so we can go ahead and look at that. And you see I have my deployment Cookie Factory. It's ready, it's up to date, it's available. And then I'm going to show you the nodes again, or pods, sorry about that. So now I actually have a pod running, and it's Cookie Factory, and then it created this part here. And I did not have to actually go in and create any specific pods. I can also scale up and down imperatively. So if I wanted more, I can do that. So I'm going to go ahead and show you that. So I'm going to scale deployments, and then my deployment was named Cookie Factory. And I'm going to give it 4 replicas. So then when I go back and get my pods, now you'll see 4 running. You see this ancient pod that is all 47 seconds old, and 3 that are 3 seconds that I just created. I can also decide to get rid of one of them. Get rid of this one. I don't like that one. Actually, I'll get rid of the 47 seconds. It's gotten too old for me. Yeah, gross, don't want it. All right, so then whenever we go back and get pods again, whenever I go back and get the pods again, what you'll see is that that one is terminating, and it has now been replaced by one that is nice and young and 10 seconds old. So that's already done for me by the deployment. I did not need to actually worry about those pods. The other way that we can create a deployment is declaratively. So I have also in here a YAML file that I can show y'all really quickly. And it just has some of the instructions for another deployment. It's going to be named Other Cookie Factory. So I'm going to go ahead and create it just from that YAML file instead. So apply. And that's been created. So now I have 2 deployments, and you're going to notice that this one actually already started up with 2 pods because I put that in the actual declarative file that I wanted 2 pods, so it already did that for me. So either or works fine. I'm going to go ahead and delete this one. I've decided I don't like it either. Other cookie factory. All right. And then finally, I'm just going to show how to expose and then curl to it. So first, I just want to create a proxy really quickly. So I need another terminal for that. Oh, okay.
Another awkward thing about kind, since there's a Kubernetes cluster running in Docker, node port doesn't actually work because there's no port on the node. It's a Docker container, and the networking with that is kind of weird. So we're using a proxy here to interact with the Kubernetes cluster instead. Oh, right, yeah. In a Mac, it's on a VM also. Yeah, it's weird. Gets weird.
I'm just going to go ahead and open up the API so you can see that I can access that Kubernetes API. And so now I'm going to curl to, I'm going to expose and then curl to one of my pods. So first, to expose it, kubectl expose, I'm going to find the deployment that I want to expose, which I named Cookie Factory. And type, we're doing cluster IP, which we just talked about. And I'm going to choose the port 8080. Ugh. Thank you. Always enjoy mob programming. All right, so service is now exposed. So I'm going to go ahead and curl to one of the pods. Let me go back and look at the names of those pods. I'll choose my youngest pod. I think we've already determined that that's always my favorite. So localhost. Oh. I'm just making sure that y'all are paying attention at this point. So 8001, API, version 1. I did not give it a namespace, so it's going to be the default namespace. And then pods. And you can actually see what the YAML file would have been to create that pod that I actually did not write. And it did it for me.
So she's going through the pod in Kubernetes to get to the API server. Yeah. But we can reach it through the cluster IP through a proxy.
All right, so I think there's about 5 minutes left if you had any more questions.
Hello?
Great presentation, thank you. I do have a question, and I don't know, maybe my question doesn't belong in this venue, but I'll ask it anyway, and just tell me to go away if it doesn't belong. That is, my most common use case is that I have a web server that proxies back to some application, whether it's a Gunicorn, whether it's something else, whatever it is, but you have a web server that proxies back. And let's take Nginx as an example, or Apache. And each one of these have their own unique configurations. And I saw in the Docker file, and the most common way that everyone does this is in the Docker file, they write copy. Hello? They write you write in the Docker file, copy this configuration from here to some location within the container. So that's great and all, but that would require you to have to write that nginx.conf or httpd.conf yourself, right? And I'm so one of the main reasons that I've been on and off with containerization, well, I use containerization, but the main thing is that I don't want to write the configuration file myself. I'd rather have it be abstracted by a configuration management system, well, Puppet, Chef, whatever, because it'll write it in the proper format for me. And when I'm not using container, let's say I'm using something like Puppet, right? I can write the configuration for HTTPD or Nginx automatically, and it'll write it for me in like the most eloquent way that it could be written. And is that still, how can that be done, or is that possible now within Kubernetes or Docker even, such that I can use a configuration management system wherein it would write the configurations for me without me having, because if you have to write Nginx configs by hand, oh my God, it's insanity, right? Server stanza, HTTP stanza, location, and then if you have to rewrite.
Yeah. So you've got
Rules.
like an Nginx or Apache web server, and you're trying to get the configuration for it. You usually use Chef or Puppet both to run the server and to create the configuration, or?
Yes.
Yeah. So you usually use it for both.
I'm focusing only on writing the configuration for those web servers.
Right.
Because running them that can be done by obviously the orchestration.
Exactly. Yeah. That's what I was thinking.
The configuration itself, I'm sorry. But the configuration itself needs to be written first, and it needs to be ingested within the container.
Right. So Kubernetes has a concept for separating the concept of the configuration into a config map, which you can then map to the workload within Kubernetes. So by separating these components, you could auto-generate it, put it into a config map, and then add it into the container. So there might be a way to make that automation smoother using config maps, is my first thought. Justin, do you have any additional
I do know
thoughts?
that some config management tools can create containers. Ansible has a container creation tool, so you can have other tools generate that for you. We are out of time for any other questions, but I know Kaslin and Christina will be around today, so find them in the hallway, and they'd be happy to answer any other questions.
I'll hang out right outside the door if you want to ask some questions.
Sweet.
It's okay. Oh, are the slides available? I haven't put them up yet, but I'll put them up in Christina's repo, and we'll make sure to share that
Yeah.
with the conference.
Cool.